Yo, 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 yo. What's up, what's up, what's up? Welcome back. Today we are working on making a QR code decoder from scratch. So we are on day 4 right now, I believe. And this is what we've got so far. Lots of colors on this grid. So, like, what are we looking at? So we can work with a perfectly aligned QR code right now. We haven't done anything to work with anything that isn't, like, if we were trying to take a photo with our camera, no shot. But we do have the ability to work with this, like, perfectly generated one. And what we do is, if you look at the actual picture, it's a little bigger than the QR code itself, and that's because the QR code spec. I didn't buy the spec because it's like $300. Not doing that. But if I understand it correctly, there's supposed to be some border around your QR code or it's out of spec. So this is what's been generated, and that means that we have to actually, to get anywhere, we have to start by finding the QR code in the image that it's in. And so the way we do that is we just kind of do one-dimensional scan lines. So we start at the top and go boom, 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 and we look for this like pattern of like black, white, black, 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 white, black. Or I guess technically, if it was inverted, we would probably still catch it. And so we kind of visualize that with these like red dots all in here. We do the same thing vertically. We see some blue dots. And then we kind of try to find areas where they're close together. So these green dots are kind of like the intersections of those lines. Then we like take that and we can like extract where these like finder patterns are relative to this, because we've know the like size that this thing is supposed to be. So we can draw a yellow box here, and from those 3 finder patterns, we can draw the bounds of the QR code. So that's what this like red box is on the outside. From there, we've looked at these like timer patterns. So there's these tiny red boxes here, and so these are just alternating colors saying like, hey, you can check this to make sure that you are actually looking at something reasonable, right? Like basically like check that you're actually a QR code, I guess. And also you could check kind of that you could probably do some sort of like adjustments if your image is a little warped. We're not doing that right now, but we might in the future. I don't really know. And then there's this like purple section, and these are the like format information. So these will tell you things like there's like this mask that's applied to the QR code as well. I think it's the version number, I think, is in there as well, where version number is kind of equivalent to like size of QR code, if I understand correctly. I don't know. I haven't really been reading much. I have just been doing. And so anything that I say is kind of just based off experience and not actually understanding anything. Okay. So from there, once we have the masking code, we should, like, the masking code, let's give an example here. So basically, if you were to encode, like, say, your QR code was just supposed to be only zeros, right? What you would end up with is you would just end up with this, like, big white box. Maybe. If I understand the alphanumeric code incorrectly. I haven't really read it, so let's just assume that you had all one character. If you assume that you had all one character and no bits were set, then you could end up with this white box, and that would be, like, really shitty for parsing, right? Because your parser should be kind of like, it could be adjusting for like image warping and stuff, and so being able to like see the grid is important. And so what they do is they apply these like masking patterns where they say, okay, we'll take your data and we'll just like drop this shit on top. Where I think I think somebody said on YouTube comments it should be called modules, indicate like a flip the thing that you're looking at, or don't flip it, whatever. White is like don't flip it. And so this, like, you check all these mask patterns, and the one that is the best ends up being applied, and then you should always have some sort of like high frequency data. Great. So once we have that mask code, we can start iterating the QR code, and that's what these orange boxes are here, and the number is like the order that we iterated, which is kind of hard to see here. Maybe we can look at like QR code zigzag, and maybe somebody will have like a better rendering of it here. So the walk pattern is pretty odd. It's start at the bottom right corner, and you go left, up, left, up, left, up. You do this like little zigzag. You do that all the way to the top, and then if you like slam into the edge, you turn around, and go back down. And if you see like timing patterns or alignment patterns or something, you kind of, I'm not really sure what the exact correct behavior is, but what I'm pretty sure it is you just kind of keep zigzagging until you get out of it. And the reason I say that is because, let's see, I saw a picture here. If you look at this like D10 here, he's kind of doing this weird zigzag where he goes zig, zag, and then here it's like, oh, he kind of has to just keep reading upwards, which is a little unexpected. So I think that it's just keep going, but I'm not really entirely sure about that. It's just kind of what we're doing right now. Okay, so I think that's everything, and so we've got all the pieces now to actually start looking at what the data in the QR code is. So the plan for today is to walk the thing in the direction like we're doing here for the orange blocks, and then I want to apply the mask as we walk and re-render the QR code, but with the mask applied, because I think that that'll be useful for like visually checking what's going on. From there, we'll have like this like unmasked version, and we can use that to parse the encoding. So if I somewhere, let's see, one of these pictures. None of these pictures are really good at explaining it, but the first 4 bits should be a encoding mode. So depending on the encoding mode, then the rest of the thing should be parsed differently. Then there's a length code, so how many bits or maybe how many bytes, I don't really know. We'll find out. And then you walk the rest and you decode it according to the decoding function. So that is the plan. And then I guess if we get through all of that and it's quick, which it might be slow. Every day I've thought that we're going to get there pretty early and we never get there. So we'll see how it goes. But if we get there pretty quick, we can try to generate some QR codes that use different encodings. And then if that works okay, we can try to look at some bigger QR codes and try to parse out the alignment markers, because we haven't detected these things at all. And so we're going to have to do that at the very least. And I find it hard to believe that we'll get farther than that. Find it hard to believe. So let's just get fucking moving. Okay. So what have we got here? We have our main function is kind of driving everything right now. And everything right now is kind of formed as these iterators. So we can say, hey, I want this data iterator. And the data iterator basically has this next function, and every time we call next, we do a move where we basically do one of the zigzags. So if here we'll just return the next bit of data, or what we return is not the next bit, but we turn a rectangle that represents the next bit. And so externally, then what we have to do is we have to take that region, and what we should probably do is check if it's light or dark, and then apply mask code. Apply mask. Yep. And then render new image. Yeah, I think that's essentially what we're going to be doing. Seems reasonable. Okay. So I guess we can just say we have this utility function is light region of interest, and we can pass in the region of interest as well as the image that we are iterating. And then we can say, is it light? Based off that. It's not called bool in this language. You write var, and then, or maybe const even. Okay. Then what we need to do is we need to flip this if the masking function says that we should. And here we parse the masking function from the format info yesterday, but we don't actually do anything with the mask function. So I guess maybe what this guy should do is for now he'll just return a function pointer. So I don't really know what the function pointer syntax is in this language. I assume it's less stupid than C's. So it's probably something like you return a pointer to a function that takes in a X and a Y position and returns a bool for if we should flip it or not. Sure, that seems useful. And then here we can say, hey, we found the mask value, and we've already looked at this one specific QR code that we're testing with, and we know that the mask pattern is 0, so we've only ever implemented this one. And he just says, hey, if my X position is modulo 3, then flip me. Which I think is... Where is that visualized? Visualized here with these black stripes. So we have that already, theoretically. Function pointers are star const. Oh, good eye. Thank you. That makes a lot of sense. And so here we should be able to just like return the mask function. This, and then hopefully if we say, hey, we want this like format info, and we will just say, const mask function is equal to this, and I guess we're just gonna say if mask function, we're gonna have to pass in the x and y positions, which we don't actually have right now. We only return the rectangle, but I guess we should return the rectangle as well as the grid position, because we need both of those things. So let's just say const output is equal to some structure, and he's going to have some ROI, which is rectangle, region of interest, as well as the x usize and y usize. Yeah, I think that's reasonable. And then when we return this guy, we are going to return an output instead of a rectangle. And this output is going to say return ROI is equal to whatever the fuck we were doing before. And now we just have x is equal to self x pause and y is equal to self y pause, and we're chilling. Which means that this is going to be an item now instead of an ROI, and then we just say const ROI is equal to item ROI const. We'll use it directly. Yeah, like this. Yep, we throw some items in there. Okay, so now we can say, hey, let's like call the mask function. Which will take in our item x and item y. And return a bool. And let's think about this. So, first of all, what is this mask function returning? This is returning, the API says true if it's 0. So I think that they said black is flip. Meaning of the format information, blah, blah, blah. Note that we map mask values, blah, blah, blah. Nothing in here looks like it's saying when to flip. But I think it is dark versions. Or the where did I read this? Can we just like control F mask? Masking needs to break up the patterns, blah, blah, blah. Mask patterns are defined in a grid. This is necessary to cover the whole symbol. Modules corresponding to the dark areas of the mask are inverted. Okay, cool. So here we are returning true when we should flip. Which means our truth table here is output value is, I think that it's the dark values are 1s as well on like the, just generally. Where do we see that? Somewhere, somebody will have to tell us. Error correction level, mask pattern, surviving a grid. Message.js says right to left zigzag pattern is shown below. This is complicated, blah, 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 blah. Where does it just tell me like whether dark is light or not? Or dark is 1? Oh! QR code decoding by hand. I think that I've been reasoning, or QR code step by step. This is a really good reference. This guy. Okay, so he will say somewhere in here, draw fixed patterns, find penalty patterns. No? This doesn't really have it either. Maybe this one. Maybe this one. I just want to know if it's dark or light. Format. Oh my god. Okay, I'm pretty sure that I read somewhere it's dark, and I'm just gonna go off memory and then get mad at myself later when it's wrong. How about that? How about that? So if it is light and true, light is 0. True means flip. This goes to 1. Dark and true goes to 0. dark and false goes to 1, and light and false goes to 0. Okay. So this is like dark, false, 1. I'm pretty sure this is like an XOR with this inverted. So yeah, so dark and true gets flipped. Light and true gets flipped. Oh, wait. Dark and false goes to 1. Yeah. So dark and true gets flipped. Light and false gets flipped. Yeah, I'm pretty sure this is an XOR. Yeah. So we can say const val is equal to output is dark XOR with this. But this is not really what we want right now. We want to start by just rendering the inverted version. Oh, but I guess we do have to like parse the value to do that. Okay. So now let's say that we'll draw out to a new image. We need a new image. So let's create some argument that is, well, we have output right now. Maybe we'll just readjust so that the output argument now goes to a folder. I think that's reasonable. So we'll say std fs current working directory create make dir creates a directory relative to the absolute path to create multiple directories to make an entire path. Make path. Okay. Make path calls make dir recursively to make an entire path. Okay, that seems reasonable. This is usually the one I want. Return success if the path already exists and is a directory. What if it doesn't already exist? I guess it will also succeed. Okay. So we'll make the path's args output. And were there any other arguments here? No. Okay. And then I guess now we just have to make a new path. We'll say that the SVG, so the like overlay file, overlay path, i.e. this thing that we've been looking at, this is now going to go to std format alloc print with some allocator, and I'm going to print the existing output path with we'll call this, I don't know, visualized SVG overlay I don't know, doesn't fucking matter. Yeah, we'll just call overlay. Fuck it. So now the SVG file goes to overlay path. This has to be deleted. Maybe this is does this just get a pointer? So I have to call alloc free on this path. Okay. And so now if I like zig build and say output test, he's going to get mad because some of this stuff isn't used. So we'll give him a sec. Alloc print requires 3 arguments, right? Of course, because I need to pass in the argument that I want to start with. Args output. Unimplemented mask function. So I don't know. This was probably like being lazily compiled. Oh, I just uncommented it. That's why. Okay. Value of type blah 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 is ignored at 205. So let's just ignore that intentionally. We don't need it. Oh my god, there's so many problems. Expected type pointer found type rect. So 214. We just throw a little ampersandy on here. Okay. Invalid operands to binary bitwise expression bool and bool. Oh, I didn't know you couldn't XOR bool and bool. I guess we'll just do this for now. It doesn't matter. We are trying to do something else. Oh my god, let me compile, please. 463. Here he's mad because he's expecting U size and he gets a I32. Oh, sure. Where these guys are I32s because it just made it easier to work with. Bool XOR is just not equals. That's a really good point. That's a really good point. Okay, so now I should have some folder test, and I have overlay SVG. Now, probably this overlay is not going to work because he is referencing the original QR code who is in like a different location. So I think probably what I'll just do for now, what makes the most sense to me is I'll just copy in the original QR code into the output, and then we can reference it and we don't have to worry about losing the original. Or we could just use an absolute path to the original or a relative path. I'll copy it in. Copying it in seems the most simple to me. So can we do something like there's got to be some sort of like copy file. Yeah. So we copy some file from guaranteed to be atomic. So what does this do? This opens the file at the source path and writes to the destination path. Okay, so we have copy file from args input to where is this going? Destination dir destination path. Okay, so the destination dir is going to be like the std fs current working directory. Can I like get a subpath? Yeah, open dir args output like this. Yeah. So we'll say try this var output dir is equal to the output path that we just made. And then we can copy from the input path to the output dir with the input name. Yes. I think that all makes sense. And we need to pass in some options, and I don't really care. So zig build run. Oops, zig build, and we do this. Okay, so open dir expected 2 arguments, found 1. What is it bitching about? Open dir requires some open options. I don't give a shit. Okay, so now if we look at test, the GIF is in there, nice. And if we go back here and we refresh, solid. Solid! Everything's back to working again. And so now we have this like output directory. I wonder if I have to close this. I might. Opens the directory at the given path. Is a system resource that remains open until it closes. Yeah, okay, so we say defer output dir close. And I guess that means that this has to be mutable. Oops, zig build. There we go. Cool. So we're chilling. And then I guess we can actually get away with not allocating here anymore. We can do output dir create file overlay path, or just like overlay SVG, and then we don't have to do this, which is kind of nice. Okay. Now we're going to make a new visualizer, which is the unmasked QR, and he is going to be based off of a new file. So this is going to be unmasked file is going to be create file unmasked.svg, and then we're going to defer an unmasked file close. Unmasked. We're going to call this unmasked visualizer, I guess. And this comes from unmasked file writer with the allocator, unmasked file writer. And maybe we make this later, because we want to have the size of the QR code as an argument here. So here's what we're going to do. We're going to take the image width is going to be QR code grid width, and the image height is going to be QR grid height. And our visualizer, I guess right now, he kind of assumes that we're going to be rendering on top of somebody. But that's not true. So for now, can we just pass in like null? And then our visualizer can take in an optional image path. And then we can say if image path, then we do this thing where we add the image in. Okay. I think that all makes sense. Unused local variables, that's fine. Unmasked file, not used? Of course it's used. What is he talking about? Am I high? Unmasked file is used when we create the unmasked visualizer. Oh, I didn't save, that's why. There we go, okay. So now what we should be able to do is we should be able to draw a box in our unmasked visualizer. Well, first let's see if the file is in there. Yep, he's in there. Cool. Let's say that let's start by just copying the original. Right? That's a good place to start. So we can say unmasked visualizer draw box, and we'll only draw the box if it's dark for now, just to get us something. I think that's the simplest thing. And this guy takes in a rectangle, so we'll draw it at oh, I guess matching the original image will be easier, because then we can just reuse the same rectangle. Let's do that. So this is image dot width and image height, and then we can just say we draw it at item ROI, and the stroke is the stroke what we pass in? Yeah, stroke is black, I guess, if it's dark. Okay, so let's just see if that does something. Error is ignored. Fuck you. We'll write try. Bing, bang, boom. And can we just look at unmasked? Okay, so that's a good sign. The question is, does it match? So here we can just kind of... I think that it does. I think that the dark guys in here sure are the dark guys in the original. I was going to fill them in. But maybe I don't have to. Ah, fuck it, we will. It's worth it, it's worth it. We'll just say fill is something that we can take in here. And if it is set, then we... Oh, this is draw text, I'm an idiot. So here we're automatically doing fill none. And I guess what we'll do is we'll just say fill is an optional string. And we can say if fill fill val, I guess we'll call it. I wish you could shadow the parameter there. That would make it nicer for me. But whatever. I guess you could get a little crazier here. You could say const fill vals equal to fill or else none. And then we can just do this one time with fill val. Okay. And so now all I have to do is fix all of the calls to draw box, which I think should all be in main. So let's do a little macro where we jump to the end of the line, write null, and hit next. Boom, 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 boom. And that's all of them. And so now all we have to do is say, we want the fill on this guy to be black as well. Okay, so this guy got filled in, and it looks like this guy hasn't been broken. So I think we're chilling. I think we're chilling. Cool. Cool, 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 cool. So now let's apply the mask. So the value is dark not equal mask function, which, yep. I guess we could have also done this is light. And then we could have done, yeah, it's fine. It's fine. We'll leave it this way. We'll leave it this way. And now we'll just say if val, if not val, then we draw the black box. I think that's right. I'm not really sure. We'll see in a second. Instead of thinking, we can just try. Okay. So what we should see is that on some columns, we see completely inverted, and on other columns, we do not. So here I'm seeing that this column here is completely the same. But the column next to it is completely inverted. Right, this second column here. And then what we should see is third and fourth stay the same, which they do not. We're actually seeing it backwards. We're seeing two flipped columns and one unflipped column, which feels backwards to me. So mask function should be returning false. Let me think about what's backwards here. So we know that is dark was correct, which means that it's either this condition or the mask function. So the mask function is saying he's taking in the x and y positions, and he's returning true 1 and 3 times, if I remember correctly. True 1 and 3 times, yes. Which means we have is dark. Okay, so what do we want to happen on this column here? We want, if it's dark, we want it to stay dark. If it's false. So if it's dark, we want it to stay dark if it's false. So is dark, if is dark equals the mask function, then this is true, which is what we want because dark is 1 is our current thought. Okay, so now let's try that again. Okay, so I see this looks better. So now we're seeing that this first column here is inverted, right? You can see all of the whites are turning dark and all the darks are turning white. And then on the next 2 columns, there's no flipping happening, which I think is good for us. And so I think now we just have to make sure that the column number is lining up. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that lines up because it's %3. So as far as I can tell, that's correct. I don't know if I would argue that this is any better in terms of like frequency, we want like more changes. Wait. Yeah, I don't know. Maybe it's fine. Yeah. We'll see. Okay. So next up would be to try to extract some useful information from here. So how do we want to handle this? So this is kind of like a state machine, I guess, where we have like state 1 is that we are parsing the encoding format. Damn, dude, I thought you were Loris Crow. Who the fuck is Loris Crow? Don't know who this guy is. VP of Community Zig. Oh, that's pretty funny. That's funny. Okay. So we have to parse the encoding format. Then state 2 is parsing the length, and then state 3 is actual data. So I guess what we do is we start with the data iterator and we say while I is less than 4, I plus equals 1. Then we can say maybe up here we split out a function for the stuff we're doing in the loop. So function handle data. This is a bad name, but I don't really give a fuck right now, you know? And he's just gonna do this stuff here. Is dark. All of this. All of this. And he's gonna return probably an error void. He's gonna take in the item, which is I don't really want to bother with the type. I guess we should qr.data_iter.output, which has to now be a public type, I guess. We need the image, which we will take in as a pointer, which means that here we need to take that ampersand away. We need the mask function. I don't want to deal with the type right now. And then we need the visualizer and the unmasked visualizer. Okay. Then we also need the allocator. Gross. It's a lot of shit. And the index. And the QR code. Jesus. All right. That's a function. Okay. So we're going to handle the data. We're going to pass in the allocator. We're going to pass in I. We're going to pass in the QR code. We're going to pass in our item. We're going to pass in the image. We're going to pass in our mask function. We're going to pass in the visualizer. We're going to pass in the unmasked visualizer. Then we're going to increment I. Put a comma after the last argument so the formatter will give each argument a line for some beauty. It doesn't... Oh, is that why it doesn't do it? Zig format source. Oh, that's very useful. I didn't know that. That's great. Thank you. That's gonna save me some pain. Because I've had some like really fucking long lines. I didn't understand why the formatter wasn't splitting them up. I mean, in reality, this should not be a function. Like, the way that this is right now is bad. But that's okay. It's okay. This can be or else. Stood log error early return or early end of data, we'll call it. And then I guess we'll just return error invalid data or something. Expected type blah blah blah. Found type. Oh, okay, so these guys have to be passed in by pointer. Probably this has to be passed in by maybe not. We'll see. We'll see the rest. Any more failures? No, we're chilling. Okay. So now we can do something like encoding is equal to 0. And he's going to be U4, I guess. And we are going to say encoding is or equaled with the item shifted left by I, assuming that it's least significant bit first, which I don't actually know. Data, okay, unused message. Bit order, 7 is the most significant bit. So it's actually most significant bit first. According to this, it's really hard to see, but these arrows, oh, fuck you, Wikipedia. This one has the arrow pointing up, which means that we're reading most significant bit first. So this is actually item shifted left by 3 minus I think. And then at the end, we can just say a print or stood debug print got encoding with some encoding. Let's see what we got. So bit shifting operation, right? So this is item dot. We have to extract the value first. So I guess handle data will return us the value. And this should be value like this. And then here we just return val. Which means that this guy has to return a bool. Easy. Valk? Val. How about val? You happy with that? Fuck you. Expected bit shifting operation, expected inner type found bool. So this should be int cast to a u4 val like this. Oops, it's as u4 int cast val. There we go. Expected val. Fine. We'll just say if val. We'll do it like this then. Fine. If you're gonna be a fucking whiner about it, we'll do it like this. Oh my god. As u4. I get it. You want me to be type correct. And it's like, I want to be type correct too, but I hate you. You know? Okay, please be the last one. Okay, so we got encoding 11. And maybe we draw this out as a Boolean first. And then we can see if we think it's right. So we got 1, 0, 1, 1. So according to this, most significant bit is the first one. So here in our picture of unmasked data, we should see 0, 1, 0, 0. And we're seeing 1, 0, 1, 1. Which kind of makes it seem like val is backwards here. Kind of makes it seem like it should be like this. So 0, 1, 0, 0. That seems more right to me. Okay, and then we can check, is that a reasonable encoding mode? Is it reasonable? Go back to 100% and mode indicator. So we see 0, 1, 0, 0. Byte encoding. So we have the phrase hello space world in our QR code. So I think that makes sense because I think alphanumeric doesn't allow spaces. So I think byte encoding makes sense, right? Alphanumeric, there's no space in here. So how do I know what the byte thing is? Number of bits in a length field. So if we're in byte, we should see 8 bits. Oh, wow. That's fucked. So how many bits there should be depends on the version info. And we haven't parsed that yet. But we'll just deal with it. Code 36 equals space. Did I miss that? Oh, it does. Okay, so maybe I have an exclamation mark in my hello world? I don't actually know that then, because it seems like alphanumeric would make more sense here. And you could see, it's possible. We do have the right numbers of zeros and ones for both of these, so we'll just keep that in mind as like a possibility. Let's just think about, like, we'll just say maybe it's wrong, and then if it doesn't make any sense, we'll come back to this. How about that? Okay. So now let's do a while I is less than 12 to parse 8 bits for the length. And fix. Yeah, it's fine. It'll fall over later, and I'm just going to be okay with that. Okay, so here we're going to say length is as u8 int cast 7 minus I. Yeah. No. I is from 4 to 12, so this is gonna be 11 minus I. So we're gonna start at 4. 11 minus 4 is 7, so this is gonna be shifted left by 7. I think that makes sense. I think. And so then we should be able to say got some length. So I got encoding here, got length. So this is going to be a number, and we'll write length. And so here we got length 11. So let's just type out echo -n hello world count characters. That is 11 characters. It could also be that DuckDuckGo decided to use byte encoding no matter what. That's like also a very real possibility. Okay. So we have the length. And that's a really good sign because that kind of indicates that like the most significant bit thing and the masking are both correct. Otherwise, we wouldn't have got 11 there, I think. Pretty sure. And then we just do the rest. So here, we're going to say, I guess really, we don't need to preserve I here. Oh, we do because we're rendering it. We're rendering the number where we started parsing in there. Okay. So here, I guess we'll just say, here we expect I to be 12. And I guess we'll just have some data. Okay. So var output, or var data, is equal to this array list of U8s. Alphanumeric can only be used with uppercase characters. Oh! Did I miss that? They do look very uppercase, eh? Yeah, that's it. Good eye. Okay. So I guess we're just going to say, we have like some next byte, who's going to be 0. And we're going to do something very similar here, where we're going to, oops. This loop is going to be almost exactly the same. So fuck all this. It's just going to be, we're going to be adjusting next byte. And item is this. Val is this. Local variable item capture from outer scope. Why? Oh, because I see, this comes from here. Okay. So now we are going to say what? Like if I %8 is equal to 0, we're going to do something. But this isn't going to be I, this is going to be like I minus 12 or something. I minus 11. Here, we'll do here. I minus 12. %8 equals 0. We push the next byte. So we try data.append next byte, like this. And then at the end, can we just print out the data? I don't know. Maybe. Doesn't seem unreasonable. I feel like I'm missing something, but maybe not. Next byte has to be flagged as a U8 here. Somewhere we fucked up our print. Invalid format string S for array list. Oh, it's here. This has to be data items. Integer overflow at this because let's see. 11 minus I. Oh. Oops. This is the wrong thing. So this is, we'll do this. We'll do this. Would I minus %12 work? I think it's not modulo 12 though, right? I might be missing something. What is that's like wrapping subtraction, but I is a U size. So I don't think that's what, then you could truncate it after. Like maybe. I think what makes more sense to me though is we'll just do a const bit idx is equal to this. And then we can call this a U3 and int cast this whole thing. And then we can shift left by bit idx. And then we will say if bit idx is equal to 7. We append the byte. Yeah, I like that. Somebody is mad about some mismatched bracket, so that's fine, that's fine. This guy is missing one here. You could use truncate instead of %8. Oh yeah, that makes sense. Okay. So this is obviously fucked. That's not good at all. First of all, let's get rid of this error. Defer data dnit. And I guess, okay, let's get crazy here and let's format this as like a hex. Do I not have, I thought I have like a hex formatter here. That must have been in a different project. I want to print this as not a string. What happens if I just print any here? What does it look like? I get decimal. Oh, wait, that looks okay. HELLO space WORLD, right? Like assuming that how do I say this? Okay, so there's obviously something wrong here where these aren't just like ASCII characters. But at the very least, we're seeing 54 in all the places where L's should be. So that's a really good sign. And is it offset by the right number? 166 being bigger than 22 feels wrong. Right? Because if this is supposed to be HE, then something doesn't make sense here. I wonder if they're supposed to be like signed. Does that make sense? No, because then it would only be negative numbers that are too large. We are shifting left. Oh, this would be 7 minus bit index maybe? Or maybe I'm pushing at the wrong time. So this is going to, yeah, this should be 0. Let's try that. No, that doesn't look right either. Okay, maybe we have to use our heads and use our brains and think a little bit. So this thing should kind of start at 7. So I minus 12. So this starts at 0, actually. Because the first I value should be 12 here, because our last thing ended with I less than 12, but then incremented it. So here I should be 12, and I is just incrementing here. So this is going 0 to 7. Which means that this should be 7 minus this thing. And this is fine. I think. E, F, G, H, E, F, G, H, I, J, K, L. Okay, wait, that seems like it might be right. Let's write this as a string again. Hell yeah, baby! Look at that! There's a hello world in there somewhere. Look at that! Hell yeah! Okay, so we also need to break out if our length is hit the edge, because there's like error correction bytes at the end, so we'll just say if data, or yeah, data items len is equal to length. We break. Uh-huh. And then that should be good. Boom. That's so sick. That's so fucking sick, man. Okay, so we did this at some point. We did this at some point. We did this at some point we read actual data. I guess it's this. Decode data according to encoding. So we did all this. And now... Dude, that's so sick. I guess there's definitely some work to be done here on making this not shit code. Maybe we like wrap decoding logic in some nice iterator. I think that makes sense. So what we really want like the interface to be is you like have the QR code and you say, hey, QR code, could you please just give me some bytes one by one? But maybe I'll do that later. No, I'll do it now. Yeah, I'll do it now. Fuck it. So this is at 5635. Okay. Syntax highlighting looks fucked. So maybe this data iterator. It's kind of like a ambiguous name now, because he's giving out like data regions. Maybe here we just give him the actual value as a part of our output. So we say, hey, this is where we got this value from. I think that makes sense. Okay. Okay. And so I guess he also needs to have his like mask function in here, which is some type that we figured out earlier. Yeah, this is this. Oopsies. That's this. Okay. Would it be nicer to use a packed struct of n bools so you can bitcast to an unsigned n of n bits? Let's think about that. Let's think about that. I feel like what I would actually want would be like a type that I can work with by index. Yeah, I think it's. I'm happy. I would probably, if I were to do it, I would do like bit addressable val. I would do something like this. And then I would have like val is a U8, and then I just have function set bit. Because I think that that's going to end up with like the same code under the hood, right? Like it has to do a shift and or. So I'm okay with writing it myself. I'm not too worried about it. Okay. So I think here him outputting. What did we decide? We decide that he outputs a value and he stores the mask function over here. That makes more sense. And this should return bool. Okay. So here, we're going to have to take in a mask function. And so maybe it makes sense to make a, like, type alias. Pub const mask function is equal to this. Then I don't have to fucking type this bullshit everywhere. Boom, like this. He is now gets to just say mask function. And now we can take in a mask function. And we just, like, write them down. I guess probably I should have saved, like, committed something before doing this so that we didn't end up in a broken state and have to, like, figure out how to get back. But it is what it is. Okay. I guess for now. Here, I think this should compile at least. Not quite. 467. So here we need to return. What the fuck is this? Come on. What is this formatting? Oh, it's because I didn't put a fucking comma at the end, like that guy said in chat. So here, if I put a comma here and I type zig format, then it stays that way. Nice. And then here we'll just say val is equal to false or something, just temporarily, just to get us compiling. Okay. Git commit -m hello world decodes successfully. I'm sure that one of these is not supposed to be double. SUCESS? SUCC. So it doesn't fucking matter. It doesn't fucking matter. Okay. So here when we generate this guy, the QR code, like, structure has all the information that he needs in order to extract the mask value. So probably he should run, like, he should just run his format iterator and extract the value from there. So 2 C's and 2 S's, really? And 2 L's? Oh, it is 2 of all of them. I was sure that I was... there are lots of words where oh, really? Only one? No. There's 2 L's here. It's double on all of them. That's fucked. Oh, there's another L in there. Yeah, good eye. Okay. So let's just run the format iterator here, because I think it makes sense. He can, like, extract his own mask format, and then we say, hey, could you give me some data? We don't have to worry about, like, passing in stuff. So he is going to discard the first 2 bits. And I guess we need an I value. So here we'll do this. This is .next. Then we just do for 0 to 3 to get the number of mask bits. Vals equal to format IT next. And we just do yoinkies. So var mask val is a u3 equals 0. Okay. Here we want to check if it's is light ROI. Oh, that's kind of odd. So right now, these, like, functions don't really take in the image that they're working with. They kind of just work with the regions of interest. But I guess taking the image here makes sense. I think that's okay. Do I have the image type imported? I do. So he's just going to do the same thing here. Yeah, that's fine. And then at the end of this, we should be able to extract some mask function. And we should be able to pass in the mask function. Okay, nothing crazy there. He doesn't like this. Okay. And this is mask val or equals this. Oh, we need to... This condition needs to be there, just without the I conditions in here. There we go. If it is light, then we append, or in. And the ROI that comes out is, this is the, we'll call this ROI like this. Boom. Okay. This will have to go somewhere else eventually too, but I think this is fine for now. And now when we have the mask function available to us, and we can just say val is equal to we we have to say, I guess it's just this is dark thing here. So just boom. Slap this in here. This is going to use the ROI directly. So const ROI is equal to this. Take it out of this return statement and save him back here so that we can use him here. I guess we'll save the X and Y positions as well. Just to avoid int casting twice because I'm a lazy bitch. Okay, so now these guys need to be, say, hey, I'm a usize. Please. Please, sir. Use the right types. And then here we can do all of this. We don't have the image available to us here, so I guess our next function will now take in the image. We could save it as well. I think that probably makes more sense. I think that makes more sense. Because we're already passing it into on construction anyways. So down here, when we construct this guy, we just pass in the image that we got here as well. Okay, and then here this becomes is light ROI self.image. Self.mask function, and then we return val as val. Does that compile? Not quite, because main 236, this iterator needs to be called with, what was it, just the image, right? I think. Okay. So now we are seeing some confusion here. So expected type const rect found const optional rect. That's confusing to me. So let's go to QR 626. What's going on here? ROI. Oh, yeah. Or else. I guess this will say this needs to fail in some way if it doesn't see what it expects to see. So this guy can fail now. And we will just say that it's like error invalid data. And maybe we log here too. And we'll say format iterator ended before we finished parsing the mask type. Good enough for me. Which means that now this data function that we call needs to have this little try on it. Little try QR code data. And now we compile, and now let's look at the usage of this guy and use the value that he returned instead of the one that we're computing on the fly. No, that's not what I want to do. Not yet. Not yet. So we want this guy to kind of return. Well, he's returning bit by bit now. So maybe now we have something that kind of makes sense. We can call this like data bit iter to disambiguate. And maybe we call this, we'll just say we want this to be called bit iter instead of calling it data. And now with that out of the way, now we can kind of wrap this thing in a byte iterator that will like collect 8 bits at a time or something. And that way we can call the bit iter, use that to draw our boxes, and use it to draw the unmasked version of it. Yeah. But then we can call the byte iter after to actually get the data. Okay, so here we'll say we have some bit iter, and we're not going to worry about actually extracting anything meaningful from it yet. Not right now, because that's going to go somewhere else later. Instead, we're just going to go back to basically while bit it next, we're just going to, I guess, draw our boxes. So that's in main, where this was doing this handle data bullshit. And all we have to do is this if val draw the unmasked version. And then we also want to draw the iteration order. So this stuff is all good as well, which means that we need this like I value to be writable. Yep. And this should be item.val, item ROI. Okay, I think we're chilling. Unused mask function at 226. Right, that makes sense. For now, we will just write that. Okay, and so now what we should see is we should still see this guy's coming out okay. This guy's coming out okay. They look the same. And then let's just rm-r test. Ooh, that's scary. Let's do this. RM these. Okay. And then run it again just to make sure that, yeah, they are being generated from the latest code. Cool. Everything's happy. Apply mask mirror image. I don't know what this is. Okay. Now we can pull out the byte iterator. Byte iterator. So here we'll just say pub function data. I guess data is the same name here. Self is a pointer to self. He's going to return some data iter, which we now can make again. Our data iter is probably going to contain some byte iterator, or the bit iterator, I guess. So we will say something like bit iter is a const bit iter, data bit iter. And it's not going to be const, it's going to be readable. And I wonder if we're going to need anything other than that. So he is going to take in self and going to return some U8. This should be data iter now. Like this. And he's just going to do whatever the fuck we were doing in this loop. So I guess, oopsies, where'd I go? Here. On initialization, he is going to take in, I guess, bit iter. I don't know. Sure. And return a data iter. And he's going to have to do these like first things, get them out of the way. So for 0 to 4, he's going to have to extract the encoding pattern. Okay. Or else we're going to have to return some sort of error. Return error invalid data. And here we can just say what? Encoding data stream ended before we got the encoding format. Okay. And we return early. Boom. Now we have this thing, item.val, and we can just say that our encoding is a U4, and we just do the same thing we're doing here. If val this. Boom. 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 In reality, I think that this should probably be split into its own function, but I'm not going to bother with that yet. And then here we're just going to say, we're going to assert that the format is equal to the only format that we support. I guess, technically, we don't really care what the format is. I guess. We can just store that here. And let the caller decide. Yep. Type 1 format. True. He's mad at me. Okay. Then we get the length, which we will also store. Which we did here. So we'll do the same thing for I in 0 to 8 now. We are going to return some invalid data if we fail to get something in here. So we'll say data stream ended for length. Then we do this. If we got a value, we int cast this thing, but this is wrong now. This should be 7 minus I, not 11. Yep. And so really, like, I'm going to show fix me here and say, like, it would be kind of nice to have something that's like length push bit item.val and then just be able to like extract the value at the end. That would be nicer. So I'm just going to put a little fix me there and I'll deal with that later. And so now we should have the length here and we store the length and we just say return. Boom. The bit iter is our bit iter. The encoding is our encoding and our length is our length. Easy. Which makes this next segment simple. What we have to do is we have to say we also want to store our bit index, right? There's going to be a U3. And our bit index initial value is going to be 0. Does it go up or down? I guess it doesn't matter. I guess we'll make them go down, because then we can just use them directly. So our bit index is going to start at 7. And we are going to do the same thing where we're going to... I guess here we're just going to say return null if we run out of bits. I'm okay with that. And we also are going to have to return null if the length is far enough. So if self length is equal to self num bytes red, we're going to return null here. We don't have like that like tracking array outside anymore. So num bytes red now just has to be set num bytes red equals 0. Okay. We append the next byte if item val next byte is or equaled with bit index shifted by 1. Self bit index minus equals 1. If the bit index is greater than 0, we can subtract 1. Otherwise, we have to set to 7. And return the value. So we'll say var ret is equal to the next byte. We return ret for resetting the next byte to 0. I think that makes sense. Are we storing the next byte anywhere? Okay. Which means that on initialization we have to set the next byte is equal to 0. Okay, and then I guess this just all goes in a loop. I think. Maybe. I don't know if I can know. So we check the number of the length. We check the item. Here we need to increment num bytes red every time we return. Is there anything else that has to be done here? I don't think so. That feels all done. Isn't that just next byte minus %1 %8? Yeah, maybe. I don't know. That's a lot of math, man. Next byte minus %1. Isn't what just next byte minus %1? Which part? No, I'm not sure. Not sure. Okay, let's extract our data iterator now. So we'll say var data iterator is equal to try QR code data. Surely we have to... Oh, we haven't written this part. So this guy hasn't taken the image. He doesn't have a self. He has QR code. And I guess we'll say self. First of all, I don't think that this guy should take in bit iterator by pointer. He needs to save him because this is going to be allocated here. So here we're going to say self bit iter is equal to self bit iter with the image. And I guess we just call data iter dot init with the bit iter. Yeah. Which is kind of weird because he becomes constant as an argument here. But I need to modify him. So how the fuck does that work? Right? Like, I guess I take him by pointer and then copy him? That doesn't make any fucking sense. I guess I have to do var bit iter is equal to bit iter in and copy him right here so that I can use him as mutable. Is that right? Hopefully Zig optimized that out. Yeah, okay. I don't know, we'll see. So now I can go to main and I can say, hey, let's call this with the image. And then we can just say while data it next, we can just print the byte. I don't really know. Do I write like a C here to say character, like in C? Maybe. Expected error union type. Oh, okay, so in our QR, we have to return an error, probably, when we generate this guy. Because probably bit iter returns an error, so we try here, we write try here. Oops, no, we write exclamation mark here. And actually, there's error cases on the data iter initialization as well. So we write try here. No. He'll automatically propagate, so I think that's fine. Next is not marked pub. Okay. Slap a little pubby wubby on here. And expected tuple or struct argument found U8. So that's probably on the debug print in main. I probably just forgot to wrap this guy in a little dot squiggly. Okay. So we did get hello world there, which is very nice. Very, very nice. Yeah, okay. So that's sick. That's a lot nicer, code-wise, I think, than whatever the fuck we were doing before. Let's kind of just, like, nuke all of this. Nuke all of this. Uh-oh. Did I delete something I shouldn't have? Why is it... The syntax highlighting is all fucky-wucky now. But it seems fine when I run it, so I'm not going to worry about it. And then here we had this handle data function, which I think just goes away completely now. Yeah, okay, we're chilling. That's a lot nicer. LSP restart? Like, what's going on here? Yeah, okay, this is broken. Yeah, am I overall happy with this? I think so. That feels okay. Feels okay. Okay. Git add -u, git commit -m, and we'll call this can decode hello world QR. Okay, so now we have options. Let's just, I guess, try a new QR code. So maybe we'll try one that's like 1, 2, 3, 4, 5. And we'll see if this still parses. Call this entitled 2, or we'll call this 1, 2, 3, 4, 5. That way we'll know what it is. So zig build, and we'll just run it with input 1, 2, 3, 4, 5.gif, output test. Unimplemented mask function. There we go. Okay. Sick. So let's see. Say try on another image. So here he's going to have mask value 10, and we need to implement that mask function. So that is somewhere. Mask function. I actually don't know which way we were calling these. So here we have 0 is mask pattern 0, so that's this one. So that means that we were using dark is 0 and bright is 1, which is confusing. Maybe we should invert that to be consistent. But maybe I just hate myself, and I'm not going to do that, and then I'll get mad later. As it goes. Okay. So 0B010. This is this one. Oh my lord. I times j percent 3 plus I plus j. What the percent 2 equals... What the fuck is that? Okay. So we'll call this... I guess this is mask pattern 2. I can decode that in my head. Mask pattern 2. And so this is x times y percent 3 plus x plus y percent 2. Great. That's super cool. Love that. This feels like I'm going to regret not testing this in some way. But we'll just live with regret. Unimplemented mask function still? Am I stupid? Unimplemented. Oh, he's printing it as found mask value. Okay, so that is 0, 1, 0. So should this not be okay? Oh. No, I don't see it. We'll say print the mask function. Print as Boolean. Like, am I high? Why is that? Maybe we're getting an unimplemented somewhere else. Oh, yeah, we are. It's at 209. 209. So it's in this inspect format thing, and we just have to not fail here. There's no reason to do anything here. Okay. Uh-huh. Oh, and I guess this guy doesn't need to return the function pointer anymore because we are extracting that later by ourselves. So this will just be a void return, and we'll just print it. Much better. Okay, so now we have tried to iterate something just absolutely brain dead stupid. But we did get farther. Okay. So let's look at, first of all, looks a little bit like brainfuck. Oh yeah, it does, just like random symbols everywhere. I think brainfuck is a little bit more structured with like these guys, but I get what you're saying. I have no idea if that mask is correct, to be honest. But we can hope for the best. We can at least check the encoding, I guess. The encoding now is different. This is 1011 is what we should get for encoding. So our encoding is 1011, which we can hope is numerical. 1011 1, 1. Does that just not even exist? It does feel like that doesn't exist. Which kind of indicates that we're masking wrong. Well, okay, we can look at... Yeah, I mean, I think we just have to, like, debug this mask pattern. Okay, so what are our options here? Our options are that the mask pattern is drawing the wrong fucking thing. Or something, or we're using the wrong mask pattern. Let's start by debugging. Let's just draw out the mask pattern and see if it is what we expect. Let's start there. So we can do something like create some mask visualizer. And we'll call this mask viz, and we'll look at this output dir create file mask2. Close it. We will say QR mask pattern 2. Let's call this, and we'll just say, what is the size of the mask pattern? This looks like a 5x5. 1, 2, 3, 4, 5, 6x6. So for 0 to 12, y value. For 0 to 6, for 0 to 12, x value. Because I want to see the thing repeat. We're going to call QR mask pattern 2. And I guess we don't even really have to render it to an image. We can just render it on the command line. I think that makes sense. So here we will render just x and y. And we'll say var c is equal to if this 1 else 0, and then we'll just render the thing. Inner loop 0 to 6. I want 0 to 12 on both, I think. I want like repetition a little bit. And then we'll just say std debug print a bool thing as a number. C like this. Okay, let's just see what we get there. Comp time int depends on runtime control flow. Fine, so this is going to be a C, U8, or bool. I guess. Fine. We'll call it U8 so that it all lines up type-wise. Expected 2 arguments. So here I have to write the little squiggly braces. That sucks. We are going to render something different here. We are going to render maybe an @ sign and a space. And maybe we will actually make this a string, and we will render 2 of them because we saw the other day that the aspect ratio is a little fucky. So here we're going to render a string, and we will render s like this. Okay. So now the question is does this match that? Dark, light, dark, light, dark, light, dark, light, dark, light, dark, light. Okay. Then we have light, 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 dark, dark, dark. That looks okay as well. Dark, light, 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 dark, 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 light, 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 dark, 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 light, dark, light, dark, light, dark, 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 light, light, light. Yeah, that looks correct to me. To be honest, that's a good sign that the mask value that we're applying, that makes me happy. Duck, duck, goose. Yeah. I am just saying 1s and 0s and hoping that you guys are tracking, eh? Duck, duck, goose. That's so funny. Okay. So I think that this mask pattern is correct. Now, if that's true, and we're not getting the right encoding, then why the fuck? You know? You know? So there's a good chance that our mask value is wrong. So before we were using the mask value 0, 0, 0. I think. Yeah. Now we're seeing the mask value 0, 1, 0. So they're both symmetrical. Well, let's actually look at the fucking picture. How about that? Let's double check that we've parsed it correctly. So this is our thing, and our format code is supposed to be the first. This is 2 bits, then 3. So we're looking at black, white, black. And this is white, black, white. So we just fucked up. Black, white, black is this one. Fuck! Oh, it's because sometimes the blacks are 1s and sometimes the blacks are 0s. And I said that was going to be a fucking problem. Why don't I ever listen to myself? Okay. So this is what's 101? That's 4, 5. So this is mask pattern 5. And this is 5 goes to 5. And then let's go back to 2. And you said I will hate myself for this later. And I was right. Yeah, so really that's like a real win for me if you think about it. Okay, so our mask function's there. Oh, and we got out 1, 2, 3, 4, 5, which is interesting. That means that DuckDuckGo decided to use the byte encoding format despite the fact that we gave them all numbers. So I wonder if this QR code step-by-step thing is going to... Oh, I can ask it for something else. Hell yeah. Okay, so let's try a numeric node. And -1 for automatic. Here we go. Okay, sick. Sick. There's a lot of things to try in here, which is kind of nice. So I guess now we're kind of explicitly saying that we're trying to get a different form of encoding. Which is actually exactly what I wrote here. So let's just, here we go. Try on another encoding. So the way that this is set up is kind of that we get data out of this iterator, and we should do something to the data depending on the encoding. So it's kind of like this, data IT encoding. If we have what are our potential values that we support right now. We have only looked at the byte one. So 0B100, which is also known as 4. So 4, we do this. Else, we say stood log error unimplemented encoding. And maybe we even write down the encoding. Yeah. And then we return. Error unimplemented. Unimplemented. Okay. So confirming that on the 1, 2, 3, 4, 5, he is not complaining. But now if we were to pull this image, save page as, this is not a picture. Oh, that's interesting. I wonder if I wonder if screenshotting this is going to cause, this is raising potential for all other types of problems, which is kind of fun. So let's just do this. We will save this picture and we will try to run this on that screenshot. So that's pictures, screenshot 2024-18 04-18. This, okay. From an API standpoint, shouldn't the iterator handle different encodings and only output U8s and the caller doesn't need to care? But like, it isn't, like, I think that it's, well, it depends on how we want to think about it. Like, what is, like, if somebody is asking for kanji encoding or numeric encoding or alphanumeric encoding, it's like, what do I expect to get from the iterator, I guess? Right? In my mind, I'm thinking the iterator returns bytes, and what those bytes are depends on the encoding. And so that's why I'm kind of saying, like, well, we'll let the iterator say what the encoding is, and then the caller can decide what to do, right? Because, like, you can imagine that if like, maybe they need to handle, I don't know how the kanjis are encoded, but if it was like UTF-8, you might need to, like, decide that you want to handle multiple multi-byte characters separately or something. Like, there might just be something that you need to do. I could see an argument that, like, no, I think that like what I want to do with the data is going to be some function. Like, probably how this will end up looking eventually is I'm going to have some switch statement that converts everything into strings. And so you would have, like, do I want to print the string or do I want to save the string? Those are dependent as well. So, like, I could see the argument, but I think I'm not going to do it that way. Okay. What does it not like here? So we are panicking almost immediately. On trying to open the image, actually. I wonder if it's because I have a squiggle in here and I have to write home streamer. I don't know if, like, maybe it doesn't decode that. Ah. Interesting. Okay, so what actually happened there was that I guess if you put the squiggly in quotes, bash doesn't expand it to the home directory. So I guess that makes sense. And then let's look at this guy. So does he look like a sane picture? It actually does look like we managed to find the QR code. So that's kind of nice. I was kind of expecting that to fall over, to be honest. But it looks like it worked, which is nice for us. And it does look like we did get some sort of valid thing out of it. It looks like the walking worked correctly, and he's saying that I got an unknown encoding 1. And is 1 the encoding we asked for? Might be. We did... Oh, I guess we didn't ask. I thought we did. Did we not ask for numeric mode here? Did it reset? Oh, and now it's a picture. Okay. Curl-o this. Wallpaper.png. Okay. The fuck? Oh, that's just not what I want. What the fuck? We'll screenshot this. We'll screenshot it again. Fuck it. Because he might be generating this on the fly with some, like, web dev stuff, so. Okay, we'll go back to this, and we want the later one, the later picture. So 15, 3, 15, 3, 4, 15, 4. There we go. Integer part of floating point value out of bounds. So this is from trying to get the width in number of elements. Oh, that's interesting. Interesting. GDB args this thing. Okay, so what happened here? Frame 6. Print QR rect. It's a big ass rectangle. Okay, so what's going on here? What's going on here? How big is the image? It shouldn't be that big. But we can check. If we go to frame 7, we can look at the image. 313 by 309. So there's just clearly something fucking wrong here. It's probably the detection of the finders fell over, which is kind of what I expected, to be honest. So can we, like, see what's around here? What are we looking at? Okay, so let's look at the finders. This is deallocate. This is nothing. Interesting. Why? Find fighter patterns maybe fell over. Let's look at the picture just to make sure that this is like actually what we're looking at, or actually what like a QR code that should work. So we are looking at pictures. This guy. Yeah. Slice pointer doesn't matter when like the 0, by the way. Oh yeah, that's a good point. But why is it 0? It shouldn't be 0. Which means that our finder stuff just didn't find anything. Oh, I guess our finder code is like really reliant on exact matches. If I remember correctly, I have a fix mean here that's like allow for any sort of error. Yeah, allow for any amount of error. So it'd be kind of interesting to... Let's just see if we find any candidates. So when we detect vertical candidates, let's just breakpoint. How to do this? Well, okay, let's like avoid seg faulting, and then at least we'll be able to get some debug data out of this and like look at it on the picture. I think that's what probably makes most sense. So where are we fucking crashing? It's that we assume that this thing succeeds. Okay. Yeah, so we can look at our QR code initialization. Wherever the fuck that is. And we just have to allow for failure here. So find finder patterns. He's going to run our algorithm. And he is just going to run step. So he's just going to say, hey, I'm going to try to detect these, detect these, detect these, detect these. And I guess what we just have to do at the end here is just check if the number of finders is what we expected. So here we'll just say if finders items.len is not equal to 3, I return error invalid data, I guess. Even though technically it's not invalid data in this case, we can pretend that we think that we're perfect. And now the question is, did we get our thing out? We did, except he didn't draw anything, which is fucking annoying. I kind of thought that we should draw finder patterns. Oh, but he didn't visualize finder state. This code must be running. Yeah, this ran, the visualize finder state stuff, and we just didn't get anything. Okay, so that kind of indicates that all of our scanline code is probably just, it's probably just saying like, it's probably just not finding these because they probably don't align correctly. We could probably check that in color paint by just counting. Oopsies. Right, so this is like 313 to, oh, sorry, it's 16 to 27. I guess it depends on if this gets marked as light or dark as well. Here's what we'll do. Let's just go in here. We know that this is where the bug is now, and we can just say, when we look for these finder patterns, can we just like allow for some error? Fuck it, you know? So let's do like a float divide on these. Or let's just, maybe we'll just print these. Printing's gonna suck though, because it's gonna print like way too many numbers. Well, I guess we can just print each scanline though. Let's do that. Let's do that. So on horizontal candidates, vertical candidates, horizontal, vertical. Let's just print out our std debug print Run length encodings is going to be some array that we print. Yeah. Yeah, sure. Oh, it's so ugly. Because each of these items is an RLE item. Okay, we're gonna do this. We're gonna print it ourselves. You can't stop me. So we're gonna say for RLE items, we'll just say this is an item, and we will print just the number with a comma after and a space. Yeah, sure. And then at the end, we can print out the end. Little square, a little end brace, and nothing. There we go. Hopefully this is a little more sane. Okay, nice. Nice. And this is actually like parsable by me, a human, with my eyeballs. We just have to go up a little bit. Maybe we'll just do a little like head-n15. Why? Oh, is it printing to standard error? It probably is. Fucking zig. Okay. Head-n30. Okay, here we go. So here we are seeing 309. So that's just white up here. And so then the first area, we're seeing 11, 79, 23. Whoa, 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 whoa. What's going on here? Then 79s and 16s. So here. Whoa, what's going on? What's going on here? Can we look at a few more lines? Maybe like 50? Oh, here we go. So this must be like, it must be doing something like walking some of these like grayscale, like there's probably some like weird shit going on here at the very top. Oh no, the 79 is just this. Right, okay. So then we're going down some more and we're trying to look for like this pattern here. So that's probably closest to this here. So it's probably supposed to be the 12, 11, 34, 11, 11 is probably supposed to be 11, 11, 33, 11, 11, right? That's 12 pixels here, 12 pixels here, 30 pixels here, 12, 12 or something, right? And so I guess we just allow for off by a little bit. I guess maybe by ratio probably makes sense. So we'll take our like reference bucket and we will just immediately make this a float. Well, that's going to cause all sorts of problems. So we'll say float from int here. Okay, and so then all of these cases where we're saying, hey, we want this thing to be exactly the fucking same. Instead, we will do some sort of like ratio. So we'll say function is same float. Is same. Sure. And we'll take some usize. Yeah, well, I guess we'll take in usize here. That'll make everything easier. I like that. I like that. So here we're going to say is same. We're going to take in A, usize, B, usize. Is same, is almost same. Yeah. And we're going to return a boolean. And we're going to say A is going to be cast to a float. So we'll call this like const AF is a F32 float from int A. And BF is float from int B. And then we'll just say AF over BF minus 1.0 absolute valued. Probably ABS. F fabs. Yeah. Yeah, so if this is less than some value. 0.1. Right, so these are close. So what's 12 over 11? 1.09. So this is like close to the tolerance. So maybe we'll do 0.2. Okay. And then this can just stay as a U size, which is nice. And then we can just say if these are not almost the same. Yeah. Okay, and that seems a lot like a macro. So is almost same, comma, bracket. Except this needs to be a lowercase a. And this also is the same, but here we just need to say ref times 3, like this. Okay, let's see what that does. He core dumped. Very cool. But I think he made it a lot farther. So unexpected timing value, panic. On panic, I think we don't get to like finish writing out our thing, unfortunately. Yeah, unfortunately. So we're gonna have to handle that a little better. But we can just maybe return early in main. And then we won't crash, and then we can look at the debug viz. Okay. So that's something. So we do draw some yellow boxes. I'm not really too happy with where these guys are ending. Right? It's not really like snapping to the box very well. But maybe let's just keep going and kind of see what happens. So let's try to build like the whole QR code. So we do get a red box around it. It is a little big. Okay. And then let's try maybe looking at like the timings and the formats. Let's see if those end up in reasonable spots. Unexpected timing value. So this is not working. But we can take a look. Yeah. So that's fucked. That is completely fucked. Which is kind of like unsurprising, to be honest. Okay, so what is causing this? The finder pattern is a little bit too big, and that's resulting in maybe like some QR, like the finder code's a little too big, so all of these guys get a little too big. When we walk the timings, we don't adjust ourselves. And so this is going to all be coming from the fact that there's like I wonder if our is light is just like not matching well enough. I bet if we were to do some like sharpening of this image, I bet you it would work. I'm kind of curious about that. So if we like, is this the same one? Yeah, if we open this in GIMP. And we like, can we sharpen? There's got to be a sharpen in here, right? GIMP sharpen. How to sharpen an image. No. Image filter, here we go. Filters, enhance. Sharpen. Okay. And here we can just kind of... That's probably good enough. Right, we just need to be yeah, let's try that. What's threshold do here? Lower is more sharpeny. Yeah, let's try that. Clipping. Yeah, okay. Let's just try that, and I suspect that we'll see better behavior, but I could be wrong. Export as work QR decoder sharp.png. So let's use sharp PNG. Boom. And let's see if that worked better at all. Interestingly, no. That's surprising to me. So I guess it's probably like the code that like determines the size of this thing. Hold on, let's look at who's determining the size. So he says, hey, I have some thing, and I am just using the center block as my length, which maybe is a problem if my center block is like erroring just a little on the large side. Length is ref times, oh no, I'm using the first block. So maybe we should average the lengths of all of these guys. Let's do that. Let's average them out. Block size is going to be, or maybe we just look at the start and end. That makes way more sense. Ref start, ref or RLE items, the last block, his start plus his length minus the start of the first guy, and we divide that by the finder num elements. That's gotta work better. And this has to be as F32, I guess, for this slope difference work. Let's see if that's a little cleaner. USize do not support field access. Oh, this is ref minus RLE items I dot start. Okay, let's try that. Let's try that. Definitely not what I want, huh? Definitely not what I want. Start plus length minus start. So maybe we log this. Let's log this. Var start. How do I want to do this? Let's log the first start. Const first is equal to RLE items I. Const last equal to RLE items I plus 4. And maybe we just log these things. First is an any, last is an any. And we log first and last. Okay, let's just see what this does. First is 152. Let's start, like, I want to go up. Can we head dash n 20, 50, 50, not 500. Okay. Start 11, length 12, and at start 79, length 11. So this should be 79 plus 11 minus 11, 79. So if our width is 80 divided by number of finder elements, which should be 7. So we should be getting like an 11 here. So can we like print what we get here as length? I guess we should actually do const length is equal to this, length equals length, and then we can log the length here. Maybe as a number. Okay, let's see what he does there. So he's getting length 11.2, which feels maybe seems right to me. So what the fuck is going on there? So let's maybe, can we hover over these things and see if the values are right? Start 11, length 12. Start 11. Oh, here, it's doing vertically. Okay, so he's going 11 down to 90. 11 to 90. Yeah, that looks right to me. So, yeah, 11 to 90 is 79. And the width of these guys is supposed to be what? 11 to 23. So yeah, like 11, 12, 32 to 67, 68. 68 minus 30, 32 over 3, 12. Okay, yeah, so 11 or 12 for the length seems reasonable. I guess maybe this length isn't supposed to be divided by finder num elements. Maybe that's my problem. Maybe I made a mistake. Oh, there we go. Let's fucking go, baby. Let's go. Okay, that's looking a lot better. Hell yeah. Okay, so now we can stop returning early and see if we get a little farther. Let's not head N50 anymore. And now we are saying we have an unimplemented thing for encoding 1. That's a lot better. That's a lot better. So now we're back to parsing this whole thing. Looks fucking good. Okay. We're at 2 hours and 7 minutes now, so I think I'm gonna call it there. That feels pretty good. I think that we made some pretty good progress today. So what did we do? We added some more masks. We kind of visualized them to make sure that they were looking okay. We managed to decode our first like hello world QR code without any error correction, but that's okay. And then we started trying to use like some other QR codes and started struggling with like the detection of the QR code in some cases. And at the very least, this one works now and it didn't before, which is nice. Yeah, so feeling pretty good. If you liked what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. So right now it's 4 o'clock Pacific time, so anytime between 2 hours ago and now. I'm not sure what I want to do tomorrow, so I'll have to think about it. But if you want to see what else we've worked on, there should be a YouTube link in the Twitch description. And in there's like playlists for all of the previous projects, so stuff like Rust operating system, neural network in Python, Rust terminal emulator, Rust diff tool, Git GUI, virtual file system. There's like some like 3D stuff, like the maze and like the stream intro, lots of stuff. So if you want to go check that out, that's available. There's a GitHub link as well for code for those things. If you can't see the links, then they're just the same username on all platforms. If you're watching on YouTube, there should be a Twitch link in the if you're watching on YouTube, there should be a Twitch link in the YouTube description if you want to swing by and say hi. Other than that, I think I have nothing left to plug. So thanks for watching, guys, and I'll catch you on the next one. Bye!